So we're gonna start by learning the new stuff that was over the homework. So yesterday we got through on page 13, so that's where we're gonna be today. On 13, we already talked about that our climate is controlled mainly by our location. But by location, so far we've established our latitude super important. We've established that the elevation will control the climate. And we talked about how being near a large body of water will also control your climate. But there's one more part of that, which is ocean current can control our climate. And I know you guys already know about at least one ocean current. What ocean current do you guys already know about? Think back to your childhood. Think your actual childhood.
I was a kid. Wait.
Yeah, when you were a kid. Like I'm legit talking about when you were a little kid. What ocean current did you learn about when you were a little kid? No. That's not it. You guys don't. Anybody remember that ocean current you learned about when you were watching movies?
No.
When you were watching Finding Nemo?
Crushing it?
With Crushing It? Who remembers what it's called? Oh, wrong movie.
Ariel.
No.
Who remembers the name of the ocean current that Nemo? Well, actually, Nemo didn't get in the ocean current, did he? It was Dad.
It was Dad and Dory.
No. How about the EAC? Remember it?
I don't remember what
It was called the EAC.
No, Miss Red.
No? All right, okay, well, to refresh your memory.
You're gonna watch Finding Nemo now.
No, wrong movie.
We're gonna have to watch Finding Nemo or Dory.
No, it's not.
To refresh your memory.
Dude. Focus, dude. Dude. Oh, he lives. Hey, dude.
Oh, what happened?
Oh, I saw the whole thing, dude. First you were all like, whoa. And then we were like, whoa. And then you were like, whoa.
What are you talking about?
You, Minnie Man, taking on the jellies. You got serious thrill issues, dude.
Oh.
Awesome.
Oh, my stomach. Oh.
Oh, man. Hey, no hurling on the shell, dude, okay? Just waxed it.
So, Mr. Turtle.
Whoa, dude. Mr. Turtle is my father. Name's Crush.
Crush? Really? Okay, Crush. Listen, I need to get to the East Australian Current. EAC.
Oh, dude. You're riding it, dude! Check it out!
Okay. Oh, sorry, that's all we got.
I need to watch the movie now.
Yep, you can go home and watch the movie. We're not watching it here. Cause we're not.
But you can learn so much.
You could learn a lot about a lot of things, but we're not. So now we're on to talking about, well, what the heck is an ocean current? What did the ocean current, the EAC, look like to you in that movie?
Vacuum on.
A vacuum? What do
Yeah,
you
it's
mean?
like a vacuum. It sucks you in.
Okay, sucks you in, yep. So it's kinda, what else did you notice about that current?
They didn't have to swim.
They didn't have to swim, it was kind of going on its own. It almost looked like a tube of water in the water. I kind of think of it as almost like a river in the ocean where that area was moving a little bit faster. You remember when the fish just got in there at the end? They were like almost holding still, and then they got in the current and it went boom and took them away. So that, that's pretty much what an ocean current is. They weren't really, I mean, they made a few things up, I'm sure, but they kind of depicted it almost like the actual ocean current.
What they make that?
Well, they made up the talking turtle part. The fact that the fish was riding on the turtle's back, I think they made that part up.
Oh, we didn't get
We're not there yet.
That.
Where's the little guy? Squirt is the baby turtle. It's Crush's son, I
He's
believe.
super sweet.
He's super cute. So we're gonna learn about ocean currents. Keeping in mind that those ocean currents are very similar to the way they depicted them there on Finding Nemo. So we're gonna actually go find the EAC.
Okay.
So I would like you to flip through your reference table until you find the EAC.
Why do we always make it right? Found it.
No, you didn't, Jeff, shut up.
Get it. You can see, Sarah. Okay.
So I'm not telling you where it is. I'm hoping you guys can find it on your own. You found it. Yeah, it shouldn't be that difficult.
I found it first.
Okay, so did we find the page it's on?
Yeah.
What page are you on?
4.
4. Now that you found page 4, which is the correct page you should be looking on, find the EAC if you haven't already.
Oh, it's right here.
Oh, it's right there. The EAC. What's it stand for?
East Australian current.
East, A, Australia, C, current. The EAC is a legit thing. Hint, it's Australia, and it's just to the east of that. If you're looking at my map up here, you can only faintly see the continents in the background. Hopefully on yours, you can actually see Australia from your, like, in
I
front
didn't
of your
even realize
face.
that those were there.
You see?
What?
I didn't even realize those were there.
Okay, then good. I'm glad we're talking about this. So on this reference table, and again, it's hard to see on mine with it on the board. Maybe if I zoom in a little bit, you can see it a little bit better. That right there is the outline of Australia. And then, so the gray part are the actual continents, and it's labeled on this map. Australia, India, Asia, North America, Europe, Africa, South America. They actually label the continents on this map. The white areas, or if you have a purple or blue reference table, then the purple or blue areas are the oceans, and again, they're labeled. So we have the Indian Ocean, the North Pacific Ocean and the South Pacific Ocean, the north part of the Atlantic Ocean and the south part of the Atlantic Ocean. And then down here, it's called the Southern Ocean. I don't think anything else is labeled. So they label the oceans and the continents, which, if you remember, we used this other map of the United States, or not the United States, of the world, when we were doing latitude and longitude.
Yeah, I remember that.
Okay, good. This map doesn't label the continents or the oceans. This map labels the plates, which I'm guessing, like North American plate, you can probably make the connection that that was North America. But like India was not labeled on here, but India is labeled on here. So they label things differently, but there are some times when you might need to use both maps together. And they are the same map in the background, but what's different about this map, as you already discovered, it has the ocean currents on it. So we do label the ocean currents, and one thing I want you to notice are the differences in the arrows. You should be noticing there's a solid black arrow,
Oh, yeah, there's a key.
and then open white block arrows, and oh yeah, there's a key. Warm ocean currents are the solid black ones, and the block white arrows, they're the cool ocean currents. So going back to that EAC, the EAC is a warm ocean current. See how it's a solid black line?
Yeah, they got you.
One other thing you should be able to see, what do you notice about all the black arrows? What are they all, where are they all pointing, or where are they all coming from? The black arrows.
Looks like they're going around.
They are going around, but in general, notice
Where
that,
they're coming from, but it's like-
so they are doing that, but what I was getting at,
Oh,
you guys are, yeah, well, of course, they're ocean currents. They're definitely gonna be in the ocean.
yeah, no, like, look like they're going.
Oh.
Oh, let's see.
Yeah, so they are going all around. Some of them are moving clockwise, some of them are moving counterclockwise. We'll talk about that. But what I did was hoping to notice all the warm ones, where are they coming from?
The East Atlantic Ocean.
Not all of them are in the Atlantic Ocean. You should notice they're all coming from the equator. They're all pretty much pointing away from the equator. So the warm ones are pointing away from the equator. That should make sense, because why does that make sense?
The equator's warm.
If it's a warm place, good, good. Now you should notice the cool ones, they tend to be pointing towards the equator or moving away from the poles. Again, cold ocean currents coming from the places closer to the pole. The East Australian current is a warm ocean current. The West Australian current is a cold ocean current. I do think they did that on purpose and represented, Crush. And, they represented him as like a cool surfer dude, like gnarly man. I think if he had been riding in a cool ocean current, they probably would not have had him be a cool dude turtle and maybe been more of like a cold weather fish that we're more used to, like maybe like a whale or a walrus or something different that represented cold places.
Polar bear, anything with a
It
W.
might have been a polar bear. It would have definitely been written differently if he was riding in a cold ocean current, maybe a narwhal, right? They come from cold weather.
What
I don't
about? oh,
Unicorn of the
oh.
sea.
So Nemo, while there was some fictional parts of it, came from a real place. Now I want to talk about what these ocean currents do for the weather of an area or a climate of an area. So we don't live near an ocean. We're about right here. There's a good ways away from the ocean. So ocean currents don't really affect us here in Buffalo, but they do affect New York City. You got New York City with on the water, right? The ocean.
Yeah. Is that an ocean?
Yeah. Can you picture the Statue of Liberty, which is in New York City? What's all around the Statue of
Water.
Liberty? It's the
Water.
water. And again, it is because that's where all the immigrants came. They came on a boat.
Okay, yeah, what ocean?
What ocean? Okay, well, let's figure out what ocean. Everyone find North America.
I'm probably.
Atlantic Ocean.
North America. We're about here. Again, we can't tell exactly where we are on
I
this
can.
map, but we're where the two smaller lakes touch. And then hopefully you know that New York City is to the east of us a little bit. If you didn't know, that's why you have maps of maps of New York. Here's Buffalo. Go a little bit southeast and you get to New York City. So you can see that New York City is, oops, wrong map. Let's say where'd the arrow go? There we go. New York City is, right here on the coast, and there's an ocean
I
current.
found it.
Good. There's an ocean current that is affecting New York City. Which ocean current would affect New York City?
Stream.
The Gulf Stream. And if you look at the key, it's a warm ocean current. Now, New York City isn't like a tropical place, but New York City, would you ever consider that to be like the South?
No.
No, they're right pretty close to being lined up with us latitude-wise. But New York City very rarely gets like blizzards or mountains of snow. Why might that be?
Because of the ocean.
Because of the ocean. They have two things going on. Not only do they have a warm ocean body or warm ocean current right next to them, they also have that whole nearness to a large body of water that we talked about yesterday. So these ocean currents will help control the climate of the area, whether they're getting a warm or a cold ocean current.
So basically, Tom, New York City.
That is definitely up to personal
No.
preference. So what I am basically trying to tell you is we need to get the notes about ocean current. And here you go. So we're on the bottom of page 13. So ocean currents, if the area is near a coast, the ocean currents will affect the temperature, and not rocket science again. Warm currents will give us warmer temperatures, cold currents will give us cooler temperatures. And again, that's on ESRT page 4. When you're done writing, why don't you try out question number 1 there on the bottom? Like I said, when you're done writing, go ahead and give question number 1 a try on the bottom of page 13. What do you guys think? Wait, did I include? Nope, I did not include it here. So question number 1 says, which ocean current cools the climate of some locations along the western coastline of North America? And a whole bunch of you are telling me 2, which, I guess we should check to see if you're right. Well, how did you go about answering this question? What were the steps you needed to do?
You find the western coastline of North America.
That's the first, guys, that might be the hard part for some of you.
Just
Find
never
North America.
Hey, you said.
Okay. Then, like Sarah said, then you go, never eat soggy waffles. Fine, waffles. Waffles is on this side of North America. So don't get overwhelmed if you remember, the map is a little weird because some people get like nervous that they're like, okay, the Western hemisphere is on this side, the Eastern hemisphere is on this side. Don't get weirded out by that. You still find North America, never eat soggy worms. And you realize that the worm side is the California current. And does it make sense that that's a cool current?
Yeah.
Yep. Or that makes it cold? Yes, because it's a cool current. Yeah, California current would then be the answer for number 1. Number 2 is, again, the same exact question that I, for some reason, wrote the answer there already. So, we're not gonna do question 2.
California current.
Yeah, California current, but again, you can see they reword, it's the same question, just reworded slightly differently. So hopefully that wouldn't have thrown you off. Identify by name the surface ocean that cools the climates of locations on the western coastline of North America. So again, you just had to find the west side of North America, and that would be the cooling current would be the California current.
So easy.
I did think it was rather easy. Let's knock off one more of these. And I do believe yesterday, one of you guys, I think, talked about how the wind will affect the climate of some areas. Let's go. Oh, that was you.
Yeah, that was the thing on our decimal table.
It does. You should notice that right there on page 14, that picture also happens to match up with, what a quinky dink, page 14, middle of your reference table. So what do we need to know about wind belts? And we actually talked about this already last chapter, so I'm gonna kind of go a little quicker through this. Wind belts, again, are caused by the rotation of Earth. Winds blow from areas of high to low pressure. Now, we did already talk about the Coriolis effect last chapter, but just to remind you, that's the bending of the winds to the right in the northern hemisphere and to the left in the southern hemisphere, again, due to the rotation of Earth. the winds control your climate? They do that because depending on where the winds are coming from, they're going to bring different kinds of weather with them. And how many of you had Mrs. Brown last year?
Me.
Sadly.
Okay, those of you who have Mrs. Brown, I hear she's a huge fan of talking about the monsoon.
You. Monsoon, yeah, I remember.
I hear she gets a little animated about,
Just a little bit.
okay, I hear she gets very into wind. And what did you just say a monsoon is? Good,
Just
she
one weird
definitely, she probably literally beat that into your head, didn't she?
Yes, it's
Strong
one weird phrase.
seasonal wind,
Supposed to say that every time.
Yeah, that's.
good,
I
I love her. Strong seasonal wind. And what did the monsoons do for the area during different seasons? They either made it dry or they made it wet. Where were the winds coming from when they brought dry weather to the area? They were coming from the land. And then they switched during the different seasons, right? And where did the winds come from during the wet season? From the water. Is that kind of like exactly what we're
No.
talking about right now?
No.
Strong seasonal winds.
I am.
No, this is it. Just get really excited about the same thing. Those strong seasonal winds, those winds control the climate. This is India we're talking about, right? But here's where Mrs. Brown and I differ. She's talking about India when she's talking about the monsoons.
You're talking about the whole world.
Yeah.
The whole, yeah, I am speaking of the whole world, but with India especially, when the wind is blowing from the land, it's gonna be dry weather, and when it's blowing from the water, it's going to be wet weather. So again, the winds are controlling the climate of India and anywhere else in the world, depending on where the winds are blowing from. They bring different types of climate to the area. The only thing I wanted to do, and Jeff already ruined my surprise, is that picture on your notes matches up with the picture on page 14 of your reference table. And the only thing that I want to do is label some of these wind belts. So the only thing I want to do is add some labels, like I was saying. So you have this reference table. Let's add some highs and low pressure. First of all, where is the North Pole?
North Pole is at the up part.
It's at the top, right? It's where it's labeled dry. I heard somebody say that. Is that going to be high or low pressure according to?
It's gonna be.
How do we know this is high pressure? Okay, so we do know that. That's one way. High, dry, cool, and clear. Dry at the North Pole. But what else about this map is screaming high pressure at the North Pole?
The arrows.
The arrows. High pressure. So remember, wind always blows from a high to a low. So now you should be seeing that 60 north area, that's going to be a low pressure. Now, guys, I can still relate this back to farts if you really need me to.
Please don't.
Remember that farts come from your butt.
Whoa.
Notice
Calm
the
down.
butt of the arrow is at the high pressure. And then farts travel to your nose, right?
You're sick.
And your nose is on your head. Notice butt of the arrow is the high pressure. So fart.
Okay.
They come out of your butt. And then the next thing you know, you smell it.
Girls don't
So
fart.
they go, girls fart. Do not make
Girls do not
yourself
fart.
try to live up to an expectation
Girls-
you cannot get to.
Girls don't-
Girls fart.
Girls don't fart.
High pressure to low pressure, butt the head. So what about the 30 north? Is that gonna be high or low? 30 north, high or low? High pressure, because we got butts there. The equator, that's gonna be a low pressure. High pressure.
Oh.
Good.
You only fart when you're about past the age of 30.
Sarah? Okay, that is all we needed to get for that. I do want to go back and go over your homework, so everybody back to page 10.
God, we have like 11 minutes.
Okay, so we're making it pretty close here.
Yeah.
Sure, I can do that. We do not have homework today, by the way, so we don't have to worry about rushing through that. So some of you said you just want me to go give you the answers first, and we'll go over some of them. Number 1, 4.
4,
Number 2, 3.
3,
Number 3, 3. Number 4, 1. Number 5, 2. 6, 3. 7, 4. 8, 4. 9, 2. 10, 3. Sorry, I got lost. And 11 is 3. Oh, I thought I gave you 13 questions. Never mind, it was only 11. So number 11, the answer was 3. There's a few I absolutely want to go over. The first one being question number 8. Let's look there. So first of all, 8, it says, what type of soil would infiltrate most slowly? We did pretty much go over a very similar question.
Yeah, because you said the clay, don't think of it as a clump, and you think of it as being smaller.
You have to look at the reference.
I guess I
page
don't need to go over it because Jeff just did it for me. When you're talking about clay, I don't want you to think of the giant clump you find in a creek. I want you to think of it in terms of earth science. Clay is the smallest particle. So if we're going to infiltrate slowly, that means we're looking for the smallest. And out of these, clay is absolutely the smallest. How come the answer was granite here? Again, we're looking for the least amount of rainwater to infiltrate. Why?
It's like all lightly packed.
Not only is it tightly packed, what is granite?
It's a rock.
It's a solid rock.
Hey, boy, Jeff.
Hey, they make countertops out of granite. Does water silk through your countertop?
Yeah.
No.
I hope not
Probably
too.
not.
Good answer. But why conglomerate? It's also a rock.
Yeah, but there's holes,
Why is there holes, a little bit of holes in conglomerate?
because it's not packed in enough.
Good. Remember, conglomerate is a sedimentary rock that's made out of a mixture of sized rocks that just get cemented and glued together.
Yeah,
So there could be a few holes in it compared to granite. How'd you guys do on these first 5 questions?
Muy bien, good.
All right.
I don't know.
You don't know?
We're just gonna try to do.
So with this question, it was talking about a field with grass being next to a field with bare soil. It said they were adjacent. Do you guys know what the word adjacent means? It's not, it's in fact next to it, not even across from it. Mr. Job and I, our rooms are adjacent. Mr. Miga, well, I guess technically there's a storage closet in the middle, but we're adjacent. Right, it's not kind of like in geometry. It is. It's what the same word. So the reason they tell you that is they want you to understand that whatever's happening in field A was happening in field B. This question reminded me of a baseball field. We have the outfield that has grass and the infield that has bare soil. So when it rains, it soaks in better in the one with grass than it does with the one that has bare soil. Are there any that you guys got wrong? Number 3. Number 3. This one was review. Whoa, review from the weathering and erosion chapter. New York State soils are mostly composed of particles that have been. Remember, with New York State, almost everything has been touched by a glacier in New York State. So that was review. How about number 4? You guys probably had no idea what that one was, did you?
I got one.
You got one? Okay, you guessed good or you used some common sense. It is number 1, but this one I never taught to you. It wants to talk about soil developing faster. Guys, what the heck is soil made out of?
Sediments and.
There's sediments, so broken pieces of rock. But that's not the only thing that
Really?
soil's made out of.
Plants, dead plants.
Dead plants. Good soil, like topsoil, is not just broken pieces of rock. It's mixed with what's called organic material. So you either mix it with manure, which if you think about what manure is, it's just plants and animals that have been digested by a cow and then pooped out. Yeah, so that's, again, still just dead plants and animals. Or if you think of like a forest, what is a lot of the soil in a forest made out of?
Plants and
The
animals.
leaves that they fall, then they decompose. That's good soil. So good soil needs things that were alive. So the best soil has a lot of organic material. If we had bare soil with no plants, which means no leaves, no roots, no nothing, the soil will develop faster when there's plants and animals.
That's why you make a compound box.
Compost.
Compost box.
Yep. That is why my chicken coop is very
So
stinky
upset.
and I'm going to take all that material and put it in my garden.
That's fine.
So again, you have a quiz on Friday. I actually changed that. I think I told you guys Thursday.
Yeah.
So I changed it to Friday. We're gonna do a smidgen of review. I posted up here that it's on,
Pigeon.
guys, be quiet. Water cycle, groundwater, and soil. I double checked. It's on pages 1 through 12 of your packet. Definitely worth reviewing a little bit of that tonight.
Okay.
And test corrections, they're gonna be due by Thursday.